welcome back to yet another episode of your Re-Educated podcast. Today we have an extremely special guest, Omri Raccah. He is a postdoc fellow at Yale and works for the Turk Brown Lab. His research is focused on understanding how the human episodic memory system supports the integration, representation, and retrieval of structured sequences. Those were a lot of big words for me to understand, so I'm excited to get into it today. Omri is a good friend of Akash, who we have interviewed earlier in the podcast, and I'm really excited for today's conversation. How are you doing?
Hey, how's it going, man? I'm so excited to be here. Thank you for having me.
Yeah, I'm really glad of how this even came together. We spent a lot of time at Akash's wedding, and I feel like you were a perfect person that I wanted to talk to and understand a lot of the work that you do. And I think memory is such an integral part of education that I'm really excited to get into it. So I guess my first question for you is, how did you find your interest in working with the brain and in memory in specific?
Yeah, that's such a great question. And I think, to some extent, it's a very difficult question. Like how do we fall into these passions that we do? It's tricky. And, as much as you try to sort of find the thread all the way back to why you're doing what you're doing, I'm not sure that I know the answer completely. But I think that, ever since I was a high school student, I was interested in these topics. I was always interested in the mind and the brain and thinking about these problems in the context of my own experience. One thing that's really beautiful about doing this kind of work is that you are studying human experience, right? I work in the psychological and neurosciences. And so you're studying human experience. So it really teaches you about yourself. So I think I've always kind of had this sort of interest, but I was a very bad high school student. I was a very bad student, right? I think psychology was maybe the only class I got a B in. So I think, part of that journey was about falling into this passion and then sort of excelling from there, and then ultimately also excelling in the subject matter. And so I think maybe the initial thing was when I graduated from high school, I became interested in artificial systems, in artificial intelligence. And at the time, obviously we didn't have these sophisticated neural networks that people are using today and these language models that people are using today. So it was really just the beginning of these kind of connectionist models beginning to take off again. Of course, they were developed farther back. And I had read a book by a man named Jeff Hawkins, who actually is the founder of the Palm Pilot, if you remember those. But he also started the Redwood Neuroscience Institute at UC Berkeley for theoretical neuroscience. And his book was quite influential. And what he wrote in the book is if we wanted to make truly intelligent machines, we should study brains. And I just was super captivated by that. It just seemed so, it really resonated with me that in order to build a truly intelligent system, we should study intelligent systems. And so when I was in community college, I was so interested in beginning to build intelligent machines, which I was pretty idealistic. I was like, this is going to change the world through studying brains. And when I had transferred to UCLA, this was my goal. And the first thing I did when I got to campus is try to find a lab to join. And I joined several labs to do this sort of endeavor. What had happened is as I was studying the brain and I was in a memory lab at the time, I realized that I was just more interested in psychology and neuroscience than I was in AI. And so the table sort of turned to where now I use a lot of machine learning methods to study neural systems. But really it is for understanding human cognition as opposed to building intelligent machines. And so I think that's a bit of the origin story of how I got into this.
Hmm. I think when I speak to a lot of people who I think who are in academia, and we talk a lot about why is it that you care about what you do, I think everybody's the fundamental thing that connects everyone is their deep desire to understand people. And it's so interesting how, based on what you study, oftentimes it feels like that is the best way to get a lens to understanding human behavior. And so for me, I'm like, okay, by understanding educational systems, perhaps we can understand the motivations of people. And for someone studying the brain, it becomes that. For someone studying biology or chemistry or physics, it becomes that which provides them their lens. And you talked a little bit earlier about how what you learn does have a direct implication on your own life. I'm very curious to just understand, one, how your work impacts the way you lead your own life, especially when it comes to memory and things like that, and what your research in cognition and what are those impacts on you?
The truth is that no matter how much you learn about this stuff, you can't truly change your behavior on the basis of it. Okay.
Mm,
So like, if you say you're studying like all the biases we have as humans, all the heuristics we use to make decisions, this is something we have to learn about. It's not like all of a sudden you can override your system. That knowledge is fascinating in the sense that for me, it reveals all these things that I almost don't have any control over.
mm,
I think maybe to some extent it allows me to think about the components of my mind, which is fascinating in its own right. But does the knowledge gained actually change the way that I spend my day to day? Probably not.
mm.
I do think there's practical applications. We'll talk a little bit about education and technology and so on a little bit later. But in terms of how I lead my own life, I think the actual knowledge has very little impact.
Hmm. Why do you think that's like a limitation of knowledge in some ways, in that it also doesn't accompany with it like application?
Well, I think there is application, right? Like I said, there's a vast application in technology and in education and in all kinds of other practical areas in medicine and so on. So there's a lot of translational things that you can do. But whether or not my knowledge about human cognition changes the way that I behave, maybe in some small ways it does, but I think in general, I'm studying these things that are almost like cognitive constraints, which are ubiquitous to everybody, and they're sort of hardwired, right? No matter
Hmm.
what I know about how to retrieve a memory and so on, my system is just going to do what it does.
Hmm.
Okay. I think that I think in some ways, the study of memory in particular can help you to learn how to learn better, right?
Yes.
But I would consider that an educational sort of application.
Hmm. So
I
yeah,
don't
I mean you
go
brought it up, so let's kind of get into that. I think that's the space that I'm so fascinated by. I kind of want to give a quick analogy that was always something that made me think about memory and connection to education a little differently. So I've always had a terribly poor memory. It's been one of the things. I've never been good at memorization outside of the 50 states and maybe the element table. I don't think I've ever memorized anything well. And when I was spending time in India, one of the things that was really fascinating to me was there is this really famous poet named Thirukkural. I think that's his name, and I think I said it right. But a lot of young kids starting from the age 5 and 6 are just expected to memorize many, many of his two-line poems. And that's like, to some extent, the approximation of how intelligent you are. The more, the better you're able to like verse these things. It's kind of the oral tradition of being able to like repeat so many things off the top of your brain, which is highly correlated to memory. And you follow down the rest of the track of education. So much of what's valued is your ability to recall and repeat something without whether you understand it or not, but your ability to repeat it word for word from whatever it is that you read or saw. But I found that the education that often we have in the States are a little different from that, where memorization doesn't seem to be the number one priority. I'm curious in your kind of learning of memorization and what your own thoughts are. What do you think is the role of, first, let's start with intelligence. It's kind of this lofty word that's kind of hard to really pinpoint, but maybe we can start at what is intelligence, but move from there to what extent does memory then play a role in intelligence?
Yeah. No, that's a wonderful question. And I think maybe it's useful to actually talk about how I think about memory to begin with,
Mm.
because I think memory is a bit of a loaded term. Okay. The first thing I'll say is, and this will, I think, help us to frame the question that you just asked. The way that I talk about memory as a scientist, and the way that I think about it is not as a thing or entity, but rather as a process. Okay. And that process has a series of computational subroutines that are going on. Okay. So there's the process of encoding new information or forming a memory, right? There's the process of retrieving a memory. Of course, there is some interaction. There may be a process of storing the actual memory, like a storage problem, like how is it actually stored in neurons? or what's the mental representation at the psychological level of a memory, and so on. So I really want the listeners to understand that memory, as we think of it, is a set of computations or processes as opposed to a thing. Okay, and under that definition, to answer your question about intelligence, I think it's absolutely a basic building block of intelligence. I think it is one of the most fundamental aspects of an intelligent system to be able to retain information, retrieve that information when necessary, use what you know in order to learn new information, and so on, is really at the basis of what I would think intelligence is. Okay, and I think that memory, is something that's so fundamental that it really takes from every other system, right? You can't talk about attention without talking about memory. You can't talk about conscious experience without talking about memory. You can't talk about your personality without talking about memory, or even just seeing an object has some involvement of a memory system, something as basic as that. Okay, so that's what I would say about it. And in addition to that, I think it's important to mention that there are different kinds of memory. Okay, we really need to be thinking about this in more of a taxonomic way. What are the different types or forms of memory? These are being delineated by psychologists for over a century now. So you may have heard terms like procedural memories or muscle memory, semantic memories, episodic memories, spatial memories, working memory, and so on. And we can talk about these different subdivisions, right? And this is an ontology that's being iterated on at all times, right? By psychologists and philosophers and so on. And so memory is not any one thing, it's a process, and there are different types. And so even when you say, I've always had bad memory, my follow-up question would always be like, what do you mean? Like, which kinds of tasks do you feel like you lack on? Are you maybe better at navigation? Navigation is a memory function, and so on.
I think, even as that was the first thing that came to my mind as you were kind of explaining the different processes of memory, rather than thinking of it as one solitary unit, even being able to be like, okay, maybe my ability to retrieve is weak rather than my ability to process, or, I think that, what is the word that you said where it like decodes it? Is that what you called it? The decoding step of it? Yeah, I mean, I think that's like a much different way of looking at memory, where it's not, it feels like memory is like a bank, and your ability to, like, you increase the size of the bank, like you're doing a great job, but there are so many different aspects to it.
Definitely. I would really say that it's a set of routines or processes, right? Like the storing, the decoding of the memory. It's not just about collecting facts. There's a lot more to what's going on here, right? Even generalizing, like how do you form new memories that allow you to make inferences to new events? That's something that humans are very, very good at doing, right? If all I ever learned was specific instances, good luck generalizing to new things, right?
So how do you feel based on the things that you've learned? Do you teach ever in kind of some of your in your PhD or in
Yeah, absolutely.
Yeah.
Absolutely.
So my question is, how do you feel like your research in memory has impacted the way you teach?
That's a great question. I don't know if you're familiar with this book by Joshua Foer, I believe, Moonwalking with Einstein. It's quite a famous book. His story is quite incredible. He was a journalist, and he started going to memory competitions to report on these memory competitions. There's these really big, American memory competitions for memory champions. Okay, and they remember an immense amount of information. And when he went, he realized that all of these memory champions were using the same method in order to remember a huge quantity of information, like many decks of cards, for example. And the method was called the method of loci, okay, or the memory palace method. And apparently it dates back all the way to the ancient Greeks. And what they essentially do is they create a mental environment in order to remember the deck of cards, for instance. And so they'll walk through their house and they'll see one card that a famous person is holding and dancing on their table holding, right? And so on and so forth. So they put the information in a spatial context and create a time-dependent story out of it. And this seems to be a really powerful method for remembering. And so the amazing part of the story is that he then went and learned how to do this method, this journalist that wrote the book, and went back to the memory competition a year later and won the American memory competition
In 1 year, wow.
in 1 year through really optimizing this method. I thought it's just an incredible story that shows you the power of like, what allows us to remember information maybe is like rooted with the way that our mind works in the first place. So we are very spatial creatures. We really love stories. We really like things that unfold over time. Space and time may be one of the main currencies of the memory system, right? And so you can scaffold your memories in ways that really allow you to get a big benefit, like using this particular method, right? We can also talk about other structured things like music and stories, which we seem to retain an amazing amount of information of. So I think there it becomes very relevant. And I think this has actually this is now applied in other fields. I'm not a medical doctor, but I know that, I don't know what they're called, but when people study medicine, they sometimes use images with stories that show the person with those symptoms and so on. And having a visual representation of a scenario really allows them to remember the information better than just an arbitrary list of terms that they have to remember.
Hmm.
I often apply this in my classroom. If I can tell a story out of the information that they need to learn, I find that very helpful.
Hmm.
Of course, visual aids are very important as well. Like we're visual creatures. There's old studies that show that we can learn over 10,000 visual images upon a single exposure.
Wow.
Yeah, that's an amazing quantity, right? So showing somebody a picture can be very powerful. And there's an entire field now about image memorability, which is really about what makes an image memorable. And I love that because it's such a simple question. And so there's a lot of these areas you can take from about how do you get the information to stick in someone's mind?
I think something that's so fascinating about this is how we might fall into the teaching profession without actually thinking about some of these things, right? I mean, I think the example you gave of both storytelling and using the visual medium to kind of evoke some sort of feeling so that the memory is retained is, I think, a phenomenal way. Do you have some examples on your own in which you were able to kind of connect the story aspect to whatever it is you're teaching?
Yeah, sure. I recently worked on some work with a music theorist, Michael Seltenreich. He's a composer and music theorist in New York, and we worked on a paper that talks about how musical scales are processed in the mind and brain. But really, the amazing thing about that research was how we came to it. And we were roommates in New York, and COVID hit. And when that happened, we just didn't have colleagues, right? There was no lab to go to. He couldn't go to his department and collaborate with people. And so we came together with two completely different sets of expertise. And we were able to create something that was completely unique through that collaboration. And I think often when I present that work, it's more effective to tell our story of how it came about than to actually just dive straight into musical scales. And I think that's just sort of a tendency that we have to just dive straight into the work, but there's a real backstory behind the work. And I find that people connect with it a lot more when they understand that sort of context.
Hmm. I mean, and it's fascinating because I think so much of how things were taught thousands of years ago were primarily through stories. It wasn't so much like, here's the moral that you need to know. It's more like, here's an entire epic. And through the epic, all the morals that we would have just simply set out will be found scattered throughout the epic. But your relationship through the epic makes it stick. And I think this approach of it would be fascinating to see how, mathematics or how different things that feel like can't be taught through stories perhaps are maybe in different places. Have you thought a little bit about how things like maybe mathematics can be taught through perhaps a story?
Question. I don't day to day think about the educational impacts of what I'm studying. Of course, we can talk about that. Education is one of my passions as well, but it should be acknowledged that there's very little crosstalk between the people that do the education stuff and the people that do the cognitive neuroscience research. And this is very unfortunate, right? So I sit in the psychology department for the most part, or a neuroscience department, and there's an education department here at Yale, and there's, I think, virtually no crosstalk between the two, right? And I think it could be very powerful to try to think about that together, because there's people that know a lot more about the education side and how to apply these things and so on, that could really help us in a collaboration to think about it. And I think that's really exciting. But there are some people that are working on it. We can get into it a little bit later. But there are some people that work at that interface, and I think it can be quite powerful.
Hmm. I mean, so that kind of siloing that ends up happening, I mean, this is a little off the track, but I'm just curious to hear your opinion because I feel like the siloing that exists in academia is really unfortunate, right? Because what ends up happening, I think, and this is something I think and I write a lot about, is that you start to feel like what you're studying somehow is not connected to everything else that's happening. When you're studying computer science and you're in your silo and you're in your building, you feel like what you're doing is not connected to art history, is not. And the thing is, that's not actually the case. It just takes the right connection to be able to figure out how all of the things that we're studying are deeply connected in some way or another.
Yeah.
What are some of the things that you have seen, if you have seen this form of like siloing, and have you seen attempts to kind of bridge them together to allow for more interpersonal, interconnected work to be done?
Yeah, that's a great question. I think that the cause of this is probably the incentive structure, right? Like if I'm doing memory research, like the people reading my work are other memory scientists, right? And so in a sense, like I'm gaining, a sense of reputation. I'm building my career through those connections, right? There isn't somebody in the education department that's immediately like, let me read this, let me share it, I find it interesting, and so on. That being said, I think there's a lot of great interdepartmental work that is happening, and I think that it's a really, really useful. And I can give some examples. A field that's really grown through collaboration is the field of psycholinguistics and neurolinguistics. Okay, these are people that have been studying linguistics, a very complicated subject, in a linguistics department. And now we're doing really productive work as cognitive scientists and in collaborations. And so I think that's a really thriving area. And part of that has to do with the really deep historical connection between the cognitive science and language, right? Starting with people like Chomsky at MIT. I think there's a lot of other opportunities there. For example, doing music cognition work. So I just told you about the collaboration that I'm doing. That really is interdepartmental. And I think it allows you to really hack the creative process, right? If you take somebody that's doing something completely different than another person and they can actually effectively collaborate, this can be amazingly productive way to work, right? If you're trying to do something original. So I think, this is growing. I think music is a really good field with a lot of theoretical foundation to follow suit in the same way that the language processing field has. There's also a lot of interesting work at the interface of cognitive science and education, even though it's few and far between. There is a researcher named Suzanne Dicker at NYU. She's done this amazing thing where she's put EEG caps on every student in the classroom. So this is recording electrical activity from their scalp. And she put an EEG on the teacher. And now she has many schools all over New York City where she does this. It's an amazing, amazing. And they've shown that the synchrony or the correlation between the students' brains relative to each other, and from the students to the teacher, and from the teacher to the student, and so on, is a marker of engagement in the classroom, is a really good biomarker for how well the student will do. Right? This is really a brain level thing, but they relate it to other behaviors as well in the class and performance and so on. So that's a really good example of that interface in education, which I think is fantastic. Even though it's few and far between, I think that's a really good example of some amazing work that's going on, and something that I think maybe your audience would be interested in checking out.
Yeah, Suzanne, I mean, I'm just trying to think. It seems kind of comical to imagine a classroom full of everyone wearing helmets. I mean, but I would be so curious to read a little bit more about that research and learn what some of the findings are.
What's amazing about what Suzanne's done is that she's also created an entire curriculum for the students. So it's actually a course about neuroscience that these high school students are taking. And I think in some cases, and maybe she'd be a great guest for you, the students are actually going in and analyzing the data, their own brain data relative to the teacher and stuff like that.
Wow.
And I think in that sense, she's really connected with both the educational
Um,
curriculum and the research, right?
That's phenomenal. Rather than making you feel like a rat in kind of this lab where you're like, all right, I'm being studied, to be able to actually have the autonomy to be like, I get to actually also see the data and interact with it rather than feeling like you're just looking at me is
Right.
a really nice twist to it. That's so cool. Yeah, I might have to reach out to, you said Suzanne Dickens?
Dicker. Mm-hmm.
Dicker. Okay, cool. Boom, wrote it down. Yeah, I mean, so I'm so curious because I feel like, you've mentioned this earlier and you talk a lot about doing science or being a scientist. I'm very curious about this idea of what it means to be a scientist. I think there are certain what's the best way? Like behavioral tendencies for a person or like thinking tendencies for a person who considers themselves a scientist or what that means. I want to kind of start at that term and kind of move forward from there. But what does it mean to you to be a scientist?
Yeah, that's a really great question. And I think we don't often get time to sort of reflect on that sort of thing. Um, I think I think that for me, I think look, I think this question is going to vary. The answer to the question is going to vary depending on which kind of scientist you ask. Okay, so my day to day is going to be very different than somebody who works with animals or works in a wet lab, doing chemistry research and so on, or a physicist are going to be doing very different work to the type of psychological and neuroscience work that I do in humans. And I think for that reason, I have a slightly different take for what it means to do science for me. And I think one of the most enjoyable parts of my job is that I feel like it's a creative outlet for me as well. Because the topics are so abstract and we know so little about how the brain works, I think it allows me to be creative in the work um, in a way that's really enjoyable, right? And the creativity comes in not just in coming up with a new hypothesis, but also in the approaches, right? Like, how do we answer this completely novel question requires creative thought. And I find that to be a big rewarding part of my job. And on the complete opposite end of the creativity spectrum, I think that doing science is a craft. I think there's a real craft in the way that you control the variables and in the rigor under which you're doing the work that you're doing. And I think it takes a very long time, right? PhDs can be 6 years long, right? That's very common. And so the reason for that is because learning how to do science properly, in addition to what that takes is really reducing your own human bias, right? That's part of the craft. How do I do the work in a methodic, in a methods driven way, is to not let my bias seep in, right? There's always bias, right? Being aware of that is part of the craft, right?
Hmm. That's
Um, so
yeah. Science is an active process of reducing your own bias.
totally, and it's a very challenging thing to do, right? How can
Mhm.
I, for example, come up with multiple hypotheses, lay them out conceptually, and test them under one task in a way that is not constrained by the way that I think the results should end up?
Hmm.
That's a big part of the job, if not most of it.
Yeah, I mean, a question I have for you, and this comes up quite often, and I think it's a really deep philosophical question that I would want to devote an entire season to talking about. But it kind of has to hinge on this idea of truth and what the value of truth is. As a scientist, I think so much of your life is approaching whatever this concept of truth is, trying to get as close to it as possible, which is the whole purpose of reducing human bias and trying to study something for what quote unquote it is. My question for you is, in your own kind of experience in understanding these things, what do you think is the value of truth? Like what does it lead humanity towards if we are to somehow, yeah, what are your thoughts on that?
Yeah, I think that that is the ultimate goal, right? We're doing science because we want to understand the true nature of something. And so I obviously feel like that's a very important endeavor. And I think it's a very human endeavor to want to understand the world around us. whether there's practical applications or not, right? What I do in the lab every day is what we call basic science. It has to do with doing science for curiosity's sake. Of course, there could be applications down the line for many things. But the reason we're doing the work and the reason we're asking these questions is really just to understand something in its truest form, right? So I do think that is the goal.
Mm-hmm.
And I do think that it's intrinsically valuable even outside of the applications.
The drive towards it is that what you're speaking on?
Yes, I think just building our knowledge of the world around us is a very beautiful human thing to do, and I think it has intrinsic value to be able to understand the beauty and the profundity of the world around us. I think um, it's just sort of a beautiful endeavor, whether you can apply it or not.
Well, because we're at this point, I want to kind of throw this popper of a question at you, but do you feel like there's a limit? Is there like a end capacity to knowledge where humans can one day reach where we know everything, or do you think it's infinite?
Yeah, that's such a good question. I would say that a lot of things that you learn bring up new questions,
Yeah.
right? Like often we work on some project and we come to a result that we're confident in and so on, and it actually just raises more questions than we had in the beginning. So perhaps you can continue to ask new questions, and maybe the way to rephrase your comment is to say, is there a limit on the amount of questions we can ask?
Mm.
Right. And so I don't know if we're ever going to reach some limit, but I do think that things are not out of the scope of our understanding. Right. I don't think there's a limit. I mean, obviously, there might be a constraint in how intelligent we are to solve these problems. But say then we build a hyper intelligent machine that helps us, then we can succeed. I do think we have our own limitations in understanding the world that are constrained by our minds.
Mm.
Theoretically speaking, if we can engage with the problems, I think we can solve them and narrow down the hypothesis space.
So I think what you just brought up right there is such a phenomenal and interesting area to explore because growing up, I used to think humans were capable of anything, right? And then I think it was only recently, I think I watched a movie or read a book where I realized, oh, like if a friend is in pain or emotional distress, I can't even feel the emotions of the people around me, let alone like, I mean, you can only empathize to such a degree, but I can't actually feel what any other person or any other being around me is actually experiencing. So that was the first time I realized, oh, that's a very clear limitation of my cognition. It is very much just for what I'm personally feeling, no one else. And I think as you expand upon this, you start to realize in which ways humans are not actually these like all-knowing, perfect kind of beings. So I'm curious if what are some of the other ways that you've noticed humans are limited in that way?
Yeah, I love your example because yours is so clear cut, right? Like I can't fully ever put myself in somebody else's shoes. And so I think that's a great one. But we have all kinds of constraints, right? There's the classic working memory constraint, since we're talking about memory.
Mm,
Um, George Miller was one of the founders of the field of cognitive science, and he has this paper, I believe it's called The Magic Number 7 plus or minus 2. Right. And the idea is that humans can only remember 7 plus or minus 2 items, or sorry, I shouldn't say remember, but hold them in working memory. Working memory is a different type of memory, right? At least the way that we define it today. So
mm,
working memory is about the ability to maintain in your mind actively some items. Okay, say you give me a phone number right now, and I don't have my phone next to me, so I have to rehearse it in my head or maintain it in some way until I get to my phone. That's what is meant by working memory. What George Miller showed is that people can remember 7 plus or minus 2 items on average, and then your performance just plummets. Okay, it turns out chimps actually have a slightly higher constraint capacity, like I think it's 9 plus or minus 2 or something like that. Of course, these are averages and they vary. And one huge result in the field was that we do this thing called chunking. So if you give me your phone number, I can actually chunk it into the area code, the next 3 digits, and the next 4 digits, and then actually hold in mind more information. Right? There's all kinds of
mm.
different ways to do. do this kind of chunking process in order to kind of abide by that constraint. But that's a really sort of famous one from the field of memory research.
I think I've taken it's called the chimp test, right? Or
Mm-hmm.
something like that. I think I've like played the game. There's a game where chimps actually perform better than
Yeah,
humans on average, and it's something to do with remembering the order of things.
that's the one. They see a sequence of
Yes.
on the screen, and then they have to hold it for some interval. We call it like a working memory maintenance interval, and then they have to recreate the sequence by tapping.
Hmm.
Those are the tests that they did to reveal that they were slightly better than humans.
I mean, it's fascinating. I saw a video of a chimp actually doing it, and I was like, "This is the most, yeah, this is magnificent." I couldn't even do this, and it's wild to see a chimp do it.
It is wild. I will say that they train these chimps for a very long.
Yeah, I mean, it just when it comes to smell and when it comes to there are, dogs' ability to smell or, uh, a different animal's ability to hold breath under, their breath underwater. It's so cool to kind of see in the world around us all these different ways in which we're actually limited. Yet there's this feeling that we can do anything. And I think the point you mentioned earlier was really helpful in that even if we're not, I feel like we are capable of building tools to help us do the things that we can't, which is something obviously most animals can't. Um,
And some of these constraints are actually, I know constraint is sort of a negative word, but like for example, often these things that we do that like make us make mistakes are actually like beneficial to us in some other way.
mm,
Right? Like a really classic example from cognitive science is the work of Daniel Kahneman, right? In Thinking Fast and Slow. So like a heuristic is a way for you to make a faster decision or assessment, even though it might be less correct. Right. So like
mm,
this kind of bias has like a speed accuracy trade off. So it's really sometimes a better way to think about it is about trade offs as opposed to limitations or constraints.
mm. So in your particular lab, what is it that you're at this current moment studying specifically?
Yeah. So what I do now as I'm asking a basic question about what I call the multisensory aspects of an episodic memory. So an episodic memory really refers to how you remember a new experience, right? This is it's thought to be a very conscious process, right? So like if we look back on this podcast later, you might reconstruct the event, right? So both the formation of that memory and the conscious retrieval of an event from your life or an experience from your life is really what I'm concerned with there. What I'm interested in with regards to it is how you bind multiple senses together when you create that experience. So if I met you for the first time, I'm likely encoding both your voice and your face, right? So there's an auditory component and a visual component. And we know very little about how we create a composite memory from multiple sensory modalities that we then retrieve, right? We all have that experience of like the classic example is like you smell something like a dish from your childhood and it brings back this entire event from your childhood, right? It's really how we think about memories.
Mm,
The reason why this hasn't been studied is because one of the main methods we use to study memory regions, which are sort of deep in the brain, like the hippocampus, is fMRI. And fMRI is recording blood flow in the brain, which is inherently slow. Okay, so auditory work usually cares about millisecond level dynamics in an auditory signal. And in addition to that, fMRIs are really loud. And so there's not a lot of auditory work that's done in fMRI. There's great
mm.
work that has been done, but there's an overwhelming amount of work in vision. And so we have this blind spot where we've kind of not worked on multisensory aspects of memory or auditory aspects of memory. And so it's an opportunity. So we're trying to work on these technical challenges in order to solve some piece of that problem.
To understand how they work together to store memory.
I'm interested in the formation part in particular.
Mm,
So in an experiment we're running right now, we're showing people multisensory movie clips. Okay, like an ambulance driving through New York City. Okay,
mm,
show them the multisensory version, the sound and the visual together, the audio visual one, or I can show them just the sound, or I can show them just the visual part. I can also take the ambulance visual and put a totally different auditory on it. And then I'm looking at these hippocampal circuits. So the hippocampus is a very important region for memory. And I'm trying to decode these different aspects of the sensory information. Like I can decode the audio visual part. I can decode just the audio part. I can decode the visual part. So we're trying to create a map in these memory regions of these different sensory aspects of information.
Wow. That sounds complicated. I mean, so what you highlighted the word formation. All memories that are formated, is that the word? Formulated are not necessarily stored. Is that true?
That's a great question. The classical theories of consolidation, which is what we call that process from going from forming to storage, say that initially you have a representation in a region that, like the hippocampus, that's creating the memory or constructing the memory, and that eventually it gets stored in the rest of your brain, in the wrinkly part of your brain, what we call the neocortex. And in that process, I believe, and I don't study this personally, that some information is likely lost.
Mm.
Right? But once you form a memory, your brain does go through a process of consolidating it. There's a lot of consolidation that happens during sleep, for example, during different stages of sleep, where you're reactivating memories in order to take what you had just learned and integrate it with the rest of your memories.
Mm.
This is what we call system consolidation.
That's amazing. I mean, it's one of my best friends, Mylan, who's also showed up on the podcast a few times. It's so interesting to think about the brain because you're thinking about the thing that's doing the thinking. It's very meta in that way. It's like it's not like you're studying something else outside of your personal computer in your brain. It's like, I mean, it's just fascinating that your brain is so cognizant of itself that it can analyze itself. I mean, isn't that crazy?
It's crazy. And it is meta, and it's brains studying brains. There isn't, an entire field about metacognition, is what we call it. And this ability of our minds to reflect on themselves, completely non-trivial. You can think about whether other species have it, right? Or if it's more uniquely human, or and so on. And so I think it's a deep question. And I think that's actually, and I know that this is an entire branch of cognitive neuroscience. There are many people, like, for example, Steve Fleming at UCL. I know your last guest was also from University College London. Steve Fleming there, that's what he studies. He studies consciousness and metacognition. It's a very important topic.
Mm. Something I wanted to kind of talk to you a little bit about. It's a small detail you had mentioned earlier, but I think it's one that's really important to me. But you talked a little bit about how you had a hard time in school when you were growing up. But psychology was the one thing that you do well. It's interesting because I actually know quite a few of my students have a hard time in school, but have this like natural inclination towards psychology. I'm curious, one, how you fell kind of you accepted the fact that okay, maybe all of these other things is not what I'm going to be doing, and you simply just like went with whatever it is that you were passionate with. And then how did you kind of allow it to blossom into this, illustrious career that you've just started, but are on? It's hard sometimes. I think for a lot of people who feel like they're not good students, they kind of just give up on it all. Like I can never be an intellectual, I can never be an academic because I'm just not intelligent. And sometimes they put themselves down. So for you to kind of break that self view of yourself and step into this academic role, what was that journey like for you?
Yeah, that's a great question. And the reason I bring it up, and I brought it up at the outset, is because I feel like and I bring it up to my students, by the way, because I think it's really important to understand that there's a lot of paths to this. There's a lot of paths to being successful at what you do. And I think that it's very easy to pigeonhole yourself into thinking, I'm a bad student, or I'm not good at this, or I'm not good at that. And I think, of course, we all have our limitations and so on. But I think it's an important thing that I like to acknowledge when I do stuff like this. I didn't start as an amazing student. I didn't always want to do this. I didn't always think I was capable of doing this because it is such a zigzag road to being successful in something that you love to do. I don't know that. I think you're right that a lot of people are drawn to psychology. I see it all the time when I teach high school classes. These kids have an instant inclination, a lot of them, to be interested in the subject matter, right? And I think it's just a general interest in people. But I think more than that, I think it's a more general thing about doing what you love, which is, a real privilege, to be able to do that, to have the support to do that a lot of the times. And I think that sort of falling into your passion and being able to pursue it is very powerful. It could change your life sort of fundamentally. And people struggle, like, what do I like to do and so on. But everybody's got interests, and it's sometimes just important to follow your gut. And I think that's what happened to me, that I just sort of started to do what I loved, and then everything became really easy. And I still do it to this day, and it still doesn't feel like work. And so I think that people have that ability, and you learn over time, right? I've been doing this for over a decade. So it's not something that happens overnight.
I'm writing this paper right now on awe, and something you're saying, I really want to ask because I think one thing of what you just said right there, which is I think really important to highlight, is this conception of your ability to fall in love with something and to continue doing it without that fire burning, without that fire kind of burning out. And I think that that's a whole separate skill. I think first developing the fire, even having it exist, is a whole separate and different thing. But then not, burning out so quickly just because of your obsession for it is also another difficult thing. What are some of the things what is it that keeps you going? I guess is what is the question that keeps you motivated?
Yeah, that's a great question. I think about that a lot too. I think that you're likely to burn out not just because of your own momentum, right? But also because these things are hard, right? It's really hard to do this work. It's the kind of work where it's like however much time you invest in it, like the better you do in it. So it can feel never ending. And burning out is something that happens, right? I get burnt out. I think that a big part of doing the work is figuring out how not to burn out. That's a huge part for me. Like for me to be able to maintain my work life balance in a healthy way is the only way I can continue to do this in a productive manner. I have all kinds of tricks throughout my day to motivate me to do things I want to do less, right? It doesn't matter how much you love a job. There are going to be aspects of it that you just have to do that you don't love, right? I'm doing things all the time that are not like, oh, I'm super passionate about this, right? And you have to find ways to motivate yourself to do it. You have to find little sparks of motivation and so on. And so I think that is a big part of the work, is understanding what is it going to take for me to continue to be motivated and to not feel burnt out. Everybody
Mm.
has different thresholds, I think.
Yeah, I mean, a big part of what you said is like understanding that there will always be things that you don't want to do. So whether it's a checkbox, whatever it is that you need to do to kind of make those parts even slightly more enjoyable. And
Right.
then the other thing I think that's complicated is how to keep the curiosity alive, to not kind of get burnt down of not simply just like I no longer have the energy to keep going, but also to keep that curious mind to alive. I think that's requires its own certain um, training. Is there something that you do to always stay curious, or do you just feel like you're just predisposed with that kind of like yeah.
Yeah, I think, the curiosity is a big motivator for continuing to do this kind of stuff. There are other motivators, right? There's obviously like career incentives and so on. And I also love the people that I work with. I think it's really important to surround yourself with people that align with you about your perspective about these things and that you enjoy working with. My PhD advisor had a big sign in our lab that said, "We don't work with assholes." I don't know if you guys swear on here.
Hmm.
But I think there's all kinds of just motivators that keep me going in this sort of thing. I don't think that my curiosity in it has dwindled. I think I'm almost just as curious, if not more curious, now about this sort of subject matter. I think as you gain expertise in it, also becomes somewhat more fun in certain ways.
Hmm.
Play with it a little bit more.
Yeah.
Yeah,
I mean, I'm writing a lot of this down, but I think this conversation sets the groundwork. We've talked about memory and knowledge a few other times on this show, but I think talking about memory is really foundational because it offers a different insight into which you can think about education. You talked about it a little earlier, the siloing that happens, and I find it terrible of how unfortunate it is that so many conversations about education can be had without actually talking about the processes that happen in the brain that does the learning to begin with. I think it's a absolutely critical element to discuss. And I think these conversations start building those interconnections between different fields to actually then be able to grow on.
Mhm. Yeah, I completely agree. I think more people should work across departments.
Yeah.
Yeah, I just met, somebody recently that's working in the history department here. And immediately, I was like, this could be cool, right? We could do like a history of memory science thing, and it would be useful and people would like. And I think that to work, say, with a historian about a topic like that, is it allows me to do things I can't imagine doing by myself, right?
Mm,
Like a really proper historical analysis of a scientific field, for example. This isn't something I would kid myself that I know how to do. And
mm,
I think it is really important. I think it's a really fast track way to do creative work.
mm,
But it's difficult. You need to find the right people to collaborate with. Sometimes people need to see the value in it. Like I said, I think there's an incentive structure that keeps you sort of siloed. And you need to find people who say, okay, listen, this might be difficult. We're going to have to share a language in talking about this stuff. I'm going to have to learn from you and vice versa. But if you can find those people, then I think it's a really great thing to do. It's something that I really strive to do in my work because I do see a lot of value in it.
mm. I guess my final question for you is what do you kind of see for yourself in the future, just in terms of working in memory? Is there something that you're really fascinated that you would love that would be kind of your ultimate kind of thing to study or learn?
Yeah, absolutely. I have a few questions that I find absolutely amazing that I would love to study. For me, I'm a postdoc here at Yale. That's a phase that you do between your PhD and running your own lab. Not everybody goes on to run their own lab. People go to industry jobs and so on, which is a great option for many people. I'm personally interested in having a lab to continue to answer these questions that would consist of PhD students and postdocs. One question that really keeps me up at night is this like storage question. And when I say the storage problem, I mean, like how is a word, for example, like the word dog, actually stored in neurons, right? I think
Mm,
assume often in the neurosciences that things are stored at the synapse, and maybe you've heard that before. But this is not a an explanation that I think is solid enough for us. Oh, it's stored in the synapse. It feels almost like an excuse to me. And so I'm excited to maybe dig into that, but I really think this is something that we might not even understand in our lifetime. Uh,
mm,
Another question that really fascinates me is the interaction between consciousness and memory. I think some aspects of memory seem to be accompanied by conscious experience, like the retrieval of events in our lives. While others, like learning statistical relationships in our environment, seem to be unconscious, right? It's not so clear cut. But I think the relationship between consciousness and memory is another question that really fascinates me.
wow. So those are the two that kind of the ultimate, I think the questions that drive us say so much about our motivations and where our careers or our lives end up taking us. But that is amazing. I mean, I definitely want to keep having these conversations and have you on every few years or so to really kind of just keep learning and growing whatever it
Yeah,
is
that would
that
be
you're doing.
lovely. This is so much fun. Do want to say one more thing.
Yeah, of
You asked
course.
earlier what doing science means to me. And my PhD advisor emphasized this, and it really, really resonated with me. And you also asked me about truth. And I think as scientists, our job and our skills are honed to generating new knowledge and interpreting that knowledge or interpreting that information. And that unique skill set um, puts us in a position of responsibility to understand what's going on in the world around us. And when I say that, I'm particularly talking about societal issues and political issues and so on. We live in a really, turbulent world, and there's a lot of things going on around the world. And these days, we're all worried about misinformation and what we can trust and what we can't. And I think that part of being a scientist is carrying the responsibility of interpreting the truth about the information that we see around us. And I think
Mm.
that's often left out, and it's something that I strive to work on, but I don't always do a great job at. But I think talking about big issues in society it should be a responsibility of scientists, due to the fact that we have this unique skill set.
Mm. You honestly said something there that talking about memory sparked another question that I have for you. I'm going to throw one more at you because I was thinking about this earlier and I wanted to ask and I forgot to ask you. Do you feel that all the technological advancements that we had recently, especially with the phone and the ability to store so much data on this kind of thing that we always have attached at our hip, has changed our ability to remember things? Or is all that changed are we just remembering different things? Or is our ability to remember completely like degenerated in some ways?
Yeah, that's a great that's a great point. I haven't thought about that problem too deeply, but you're absolutely right that we have all this information at our fingertips. I know that there's a big group of memory scientists that are now interested in the influence of our phones in general, and those people are generally interested in multitasking. And multitasking has been shown to be a thing that is really detrimental for our memories, moving from one app to the other, scrolling aimlessly, and so on. Does not seem to be so good for memory. Anthony Wagner is the professor whose lab at Stanford is working on these issues, I think, mostly.
Quick question. Does listening to music while working count as multitasking?
That's a great question. People do count it as multitasking. However, in the memory field, context is a very important construct. Okay, we know there are these amazing studies that show that if you study for a test underwater or study a list of items underwater and then take the test above water, you're going to do worse than if you take the test underwater.
Mm.
So the fact this like study to recall context is very important. Okay, and so I think if you're this is just this is me speculating. I think if you're studying with music on, you should take the test with music on. This seems to be a very good feature. You may have heard, if you're chewing gum while you study test and chew gum as well, it should help. And so this actually seems to be very true. That the context in which you learn, if you what we call reinstating it during the retrieval or the test phase, that really helps to bring back those memories. It's a good question about the music. I don't think the jury is in on it.
Mm. But you were saying something. I'm so sorry. I was like, no, that can't be true. But you're talking about how multitasking and my retrieval is, I'm on 5 hours of sleep, so my retrieval is not doing great. But do you remember what you were saying before I interrupted you?
No, I don't.
Yeah.
My memory is failing me.
But yeah, I mean, thank you for answering that question, but this was lovely. I'm really glad you were able to take
Yeah,
your
this was
time.
so much fun. I'm happy to come on anytime. We have a lot more to talk about, clearly.
Yeah. Well, good luck with everything.
Of course, you too. Thank you very much.
And that brings us to the end of our conversation. I hope you enjoyed it as much as I did. Thank you again for listening and making this process so much more enjoyable. If you haven't had the chance to already, make sure to subscribe to the podcast on Spotify, Google, and Apple Podcasts to get the latest updates on new episodes. If you've been learning useful information here, feel free to leave a review as well. A little bit goes a long way in spreading this podcast. And have a wonderful day. And as per usual, stay re-educated.